Hello, everybody. So I just want to make a video today, continuing um, the theme, which was from the previous video, talking about the Berbers, or what they call or what we call Amazigh of North Africa. So just to recap, what we talked about is, we talked about the history of the Berber people. Just the different types, because as I mentioned, there's different types of Berbers living in North Africa, and also to historical, going back again. We mentioned 10,000 years. That there was a presence, of a settlement, early settlement, which I believe were to be the natives. Now, just myself, just to again, just to recap, I'm from Algeria myself, from North Africa, part of the Maghreb area, which encompasses, Morocco, Algeria, Tunisia, and Libya. So that's my roots. So my roots now, I'm from more the eastern Algeria. So we're talking about Annaba, Tebessa. We're talking also too. We're talking about the history of the Berber people and the different civilizations that were, that occupied, northern Africa. So including the Greeks, the Romans, the Byzantine, Phoenician. So last video was talking about the Berber people, and just to get a what they call sense, of how long they existed. The genetic evidence, especially when they mentioned the EM81Y chromosome haplogroup, which is highly prevalent among the Berber population. The other thing that I wanted to now further elaborate, and especially in this video, is the past. Let's talk about 10,000 years, when there was a Green Sahara. Because at that time, I believe, at the time of the Green Sahara period, I am sure there was more a more presence, in the Maghreb, or North African region. So what I want to talk about now, so as I mentioned, is the Green Period, or what we call the Green Sahara period. What we call, I'm just want to see here, the African Humid Period. So this here, it was a time when the Sahara Desert transformed into a lush green landscape, with rivers, lakes, and abundant vegetation. And now they mention here, again, this is doing research on the internet, is the age is about between 10,000 to 5,000 years ago, with variations in the timing, depending on the regions. And this is all due to a climate shift, which caused by changes in the Earth's orbit. Which increases the strength of the African monsoon, bringing more rainfall in the Sahara and allowing vegetation to flourish. So the timeline now. So they talk about 3 different timelines. So the timeline of the Sahara Green Period, they talk about the early phase. So that's about 12,000 to 10,000 years ago. So that's when the Sahara began transitioning from an arid desert to a wetter environment, initiating the growth of grasslands and freshwater sources. What's interesting that they mention is that transitioning from arid desert to a wetter environment. So I have this website that I just would like to share it. And now it's called Skymarvels.com. So I have put a link in the description in the previous little preview of the video that I'm making today. And I'm going to use this as like a baseline, so it's like of geological evidence, just saying, just showing like, graphical representation of the Earth, specifically in the North African region. So as you can see here, and if you look here, is that you could see right now this is at the year 0. So right now, and specifically I put the Ice Age Earth period. So if we actually go back, and I can move this here, as you can see, as I go back here, 5,000 years, 6,000, 7,000, 8,000, 9,000. So they're saying 12,000 to 10,000 years ago. So we look at here, as you can see, right? 12,000, you could see here, between 12,000 and then 10,000, you could see that there's a lush period here. Especially, when you go to about 9,800 BC, you could see like, the area's more lush green. See? And then as we keep on going, 8,900 BC, and you can even see a lake in the middle there, and then as you can see 7,000, it turns again back to desert, as you can see here. So yeah, so again, so 12,000. See, again, if you go back, if you keep on increasing, you see again there's it's a desert period. See, so it's interesting how there's a different transition here. But let's go back here to 12,000, 11,000 here. So that's the early phase, right, of the Green Sahara. So next we have the peak green phase, which is about approximately 10,000 to 8,000 years ago. And so this was the luscious phase, with vast grasslands, lakes, and rivers across the Sahara, which again is 10,000, 8,000. As you can see here, you can see the lush area here, especially if you go to 9,800. That's where you can see a lot of the green area. Again, I can increase this here to actually show you, the actual lush period here. Then we have the third phase, which is a late phase around 7,000 to 5,000 years ago. This, as you can see, the climate began drying, and by around 5,000 years ago, the Sahara was gradually reverting to the desert condition, which again pushed people, and animals toward more hospitable areas like the Nile Valley. So again, we go 7,000. See, as you can see here, to around 5,000, you could see, then 4,000, that becomes, more desert-like. Till about the present day, as you can see here. We're like, let's say 2,000, can't say 2,100, but that's the current around the current to the current era. So Green Sahara. So in this phase here, so again going back here, just going back to about 9,800, about there. So civilizations and human settlements in the area. So again, during the Sahara Green Period, early human groups inhabited the Sahara, and they developed what researchers consider proto-civilizations or complex societies. So these early populations were likely semi-nomadic, transitioning between hunting-gathering and early forms of agricultural and animal domestication. the early human groups and cultures. And again, if we go to 10,000, 8,000 years, so this culture centered around the now dry lake Megachad in central Sahara, which is composed of hunter-gatherers who fish and hunted large animals. So they have archaeological sites, places like in Gobero, Niger, which yielded what we call Kiffian skeleton remains and tools. So this is what we call the Kiffian culture at that period between 10,000 and 8,000 years. Then between 7,000 to 4,500 years ago, we have the Tenarian culture. So as the Kiffian culture faded, with increasing desertification, so again, 7,000, 4,000, around here. So the Tenarian people took their place. So they took the place of the Kiffian culture, who were around 10,000, 8,000 BC. So the Tenarians were also semi-nomadic, right? But they practiced, cattle herding and engaged in early forms of ritual and burial, with evidence found in Gobero. Next, we have the domestication and Proto-Berber influence. So there's early evidence which suggests that early Saharan communities may have been among the first in Africa to domesticate cattle. I remember in the last video when we mentioned about that, we talk about the rock art in the regions like Tassili and Jer, right, which is in present-day Algeria, which shows scenes of people herding cattle and even performing ritual dances, so indicating a structured social life. So these practices are seen as foundational to later Berber culture and are believed to have influenced Berber-speaking populations that settled the Maghreb, which again we call the North African region. They do mention influences on the Nile Valley civilization, so that's in Egypt. So they mention as the Sahara dried up, many Saharan people are believed to have migrated eastwards, right, to the Nile Valley, contributing to the rise of early Nile civilizations. Now we can mention ancient Egypt, pre-Pharaoh, period. So this movement may have brought early farming and herding practices to Egypt, potentially influencing the foundations of Egyptian society. So next, now we talk about the civilizations, the culture, the Berbers, the Proto-Berbers, especially in the Maghreb region. Also, we have to mention wildlife, right, in the Sahara Green Period, because obviously there's, it was different during this period here. So there was, I'm sure, different types of wildlife. So and again, it was, humid, fertile environment. So what we talking about when we talk about wildlife, evidence, there's evidence of fossils. And again, rock art, revealing the presence of elephants, giraffes, rhinoceroses, hippopotamuses, and even crocodiles. So they would have thrived more in the grasslands and lakes that dotted the Sahara. Also, we have antelopes and gazelles and other grazing animals which roam the savannas, which forming part of the ecosystem that supported human populations, right? Because where there's wildlife, there's humans presence as well. Big cats and predators. So at that time, lions, leopards, and cheetahs, likely hunted these herds. So we're talking about antelopes and the gazelles, which forms a food chain similar to that of the African savanna today. So which today's period, which if you go down a little bit, central, Africa here. Birds and aquatic life. The lakes and rivers supported abundant fish species. Like if we're talking, there's rivers in the North African region. So I'm sure they would have had rivers and lakes as well. So different fish species, which humans would have relied on for food. Fossil evidence also suggests a variety of birds, including waterfowl, due to the numerous water bodies during the Green Sahara period. So we also, again, we mentioned Tassili and Anjar, which is in southern Algeria. That's the Sahara, and and the depiction, in the art of the animals that they showed there, which makes sense, that at if you're talking about the period of about 10,000 to 8,000, then there would have been humans interacting with the animals, and and that's the importance of their way of life. And then we mentioned the decline of the Green Sahara, and which was around 5,000. They mentioned 5,000 BC, but if I move the scale here, you could see 6,400. You could see that it becomes starting to slowly become desert-like here. See, there we go, until 3,400. And see, as you can see here. So what we can say then, the Saharan Green Period, it supported a vibrant ecosystem in early human cultures, that would leave a lasting influence on the North African history. Now, there he said, while not a lost civilization in quotes, in the sense of advanced urban centers, these communities were highly adapted to their environment, and their practices and traditions likely contribute to the cultures that developed in North Africa. So this includes the Berber-speaking population. The interactions between these Saharan groups and emerging Nile Valley civilizations likely helped shape the early development of complex societies in Africa. So now the other mention is there must have been some sort of change in the earth. The earth does, the Sahara does not just turn into a green lush period, and then from green lush period to a desert period. And from 10,000 before, again, there's a desert period. There's a desertification period as well. And you can see, up at the top here, these are the glaciers, because that likely is, again, indicating, this is during the Ice Age period, as you can see here. See that if you go to the Americas, part of majority of North America was, covered in ice. And we're talking about 19,600, and then as we keep on going down, 16,000, as we keep on going, 12,000, see it shrinks, the glacial period shrinks here. And then going back here, this is again 9,700, the green Sahara period here. So one of the things that they mention of these cyclical changes, because when we mention the Green Sahara, it looks like this is not the first time that this happened. So this period, the 9700 BC, was a remote time that we know in history. Besides that, as you get older and older and older in the timeline, then it gets harder to kind of pinpoint, because Earth was not the same, right? If we're talking 20,000, talking about hundreds of thousands of years ago. I could even show you even like how the Paleolithic, Earth here, which is, if you look at it, is totally different. But I do not want to get into that right now. I just want to get into more of the greens again, which is in this video is focusing on the Green Sahara period. So what you can say is that climate change, from desert to lush savanna and back to desert, is largely attributed to long-term shifts in the Earth's orbit. Now, particularly, and I mentioned this, in our last video, was phenomena called precession. So, Earth's precession, along with orbital variations, drives cycles of climate change known as the Milankovitch cycles. So I'm going to hold that thought. I'm going to mention. We're going to get into what we call the Milankovitch cycles. So here's how the precession and other orbital factors influence the Sahara's climate. So the first one is what we call Earth's precession, or the wobble of the Earth's axis. And I'm going to show a different video here from Skymarvels.com. Again, it's an excellent tool here, which you can view, like, Earth, the historical, like what you're seeing here, the different periods of the Earth, climatic changes, and also too for what we call the precession period here. So if I go here, precession of the equinox. So here you see the Earth, it's wobbling, and not only is it, you could see the axes here, but that little blue period, that little blue circle there, is what we call the precession of the equinox. So the precession is the gradual wobble of the Earth's rotational axis, so which completes a full cycle approximately every 26,000 years. So the actual number is 25,800, but they're saying, the round off is 26,000 years. So this wobble affects the timing and intensity of the seasons, so particularly in relation to Earth's distance from the sun during each season. So in periods when the northern hemisphere tilts towards the sun, right, during summer, so closer to the sun, it receives more intense solar energy. So what this does is that it intensifies the African monsoon system, which then, if we make sense here, it brings increased rainfall to the Sahara, which then we have, that period, where we have the Green Sahara period, right? So during the Saharan Green Period, so again, which is approximately 10,000 to 5,000 years ago, the northern hemisphere experienced warmer summers due to the precession. So this boosted the monsoon, creating a wetter, greening Sahara. So here, as you can see here, is mentioned here. So you can see this great animation here, which shows a precession, which I agree myself, like, if we look at this would definitely cause, different climatic changes, during the 26,000 years. So we have here a little article here. So how a wobbly Earth and Green Sahara led to the spread of humans. So what we look here is that it says, here, here's an interesting tale, and it takes place in the hot, arid Sahara Desert in Africa. And they say actually it takes place in the warm, wet, and green Sahara. So the Sahara Desert was not always a hyper-arid, dune-swept region it is now. It has been lush, green, damp, and full of rivers in the past. And they say, in brackets, about 230 times in the last 8 million years. And they say every 21,000 years or so. So if you think about it, 21,000, and the precession is about 26,000 years. So this is like a period, the 21,000 period of the precession, right, would make sense, would indicate the green, lush Saharan period. So during these green periods, vegetative corridors created distribution channels for various species, including humans. Let me say here, so how did the Sahara change so much? What led to the climatic variations that changed the desert into savannas? And they talk here, again, it comes down to the Earth's dance in the Milky Way. The past changes occurring in the Sahara are linked to cyclic variations in the Earth's orbit. And to understand this, one needs to know how our Earth moves. And we all know that the Earth rotates every 24 hours, causing day and night, yes. And that it undergoes a 365-day revolution around the sun, causing seasons. And then, but they say here, but did you know that every 100,000 years, imagine that, 100,000 years, the shape of the Earth's orbit shifts between circular and oval, a phenomenon known as eccentricity. We will get to that. Again, with regards to eccentricity. And that every 41,000 years, the tilt of the Earth's axis changes, termed obliquity, between 21.1 and 24.5 degrees. So these changes in the eccentricity and obliquity cycles are responsible for driving the ice ages. And look when they mention ice ages, not ice age, right? So that means then the cycle of different ice ages of the past 2.4 million years. So furthermore, the Earth is not a perfect sphere, so it bulges at the equator and is influenced by the sun's gravity, moon, and planets. And they say, just like a spinning top, it sometimes wobbles during its rotation. And this is what we call the precession, right? And is defined as a slow change in the direction of Earth's rotational axis. And it varies on a 21,000 year time scale. If they talk about the Green Sahara period, right here. And they say here there are no prizes for guessing then that the 21,000 year precession cycle is linked to the 21,000 year timing of the wet Green Sahara period. And they talk about, how does wobbly Earth make a desert go green? So firstly, one needs to understand what climate systems influence North Africa. So these regions' climate is governed by three different systems: the northern Mediterranean, northernmost Atlantic coastal belt of westerly rains that fall mainly during late autumn to early spring, and the west and east African monsoons, which bring summer rains to the subtropical regions, located west and east of the River Nile. So when the Earth wobbles on its axis, the precession at different times during the cycle, seasons will become more or less extreme in the northern or southern hemisphere. When the precession causes the northern hemisphere to be closer to the sun during the summer months, there is an increase in North African summer rainfall. And they say this happens because of an increase in the amount of solar radiation in the tropics, which is the engine that fuels the monsoon system. And then this then results in the enhancement of eastern African monsoon summer rainfall over the southern part of the Nile catchment and the Ethiopian highlands, and also causes the intensification and enhanced northern penetration of the West African monsoon summer rains over the present-day Sahara. So during these times, increased rainfall and solar radiation resulted in the greening of the Sahara, with swaths of savanna vegetation and abundant lakes and rivers, as I showed you in the previous video. So these are the so-called Green Sahara periods, GSPs, or the more prosaic term, North African Humid Periods. So, and then they keep on mentioning about the Green Sahara period, and how do we first learn about these wet periods in the Sahara? And again, they mention here, about here the humans living during those greening periods told the story of antelopes, crocodiles, hippos, and giraffes through the language of art, which we mentioned about the rock art in the Tassali and Nanjar region, which is in southeast Algeria. So that's the 1,000 year. And they talk about, so how did the greening of the Sahara change humankind's journey? And we see, and what's interesting here, look, so we need to keep the bigger picture in mind. And they said here, the Sahara Desert takes up 9 million square kilometer. 9 million square kilometers, so 1/3 of the African continent. and when dry represents a significant barrier to the dispersal of species, including ancient hominid races. And then they say the theory is that these Green Sahara periods led to vegetated corridors, which then allowed changes in species distribution and evolution, and may have facilitated the out-of-Africa migrations of ancient humans. So humans, right, they moved around, right, because there was more green. They could, not desert-like, the harsh desert. So these fertile phases presumably result in a significant expansion, of human populations, which may in turn have increased the number of favorable genetic mutations, which underpin the speciation of hominin lineages. So they keep on, and then they keep on talking here about the, about the environmental changes, but this is a great article that I found here. It's called, africageographic.com. I'll put this also too in the this link in the description for you to look at. So we talked about, again, Earth's precession, right? So that's here how Earth moves against in the basically it wobbles on its axis. The next thing that they mentioned is the eccentricity, or the shape of the Earth's orbit. And I can do like a video here. So eccentricity, so here's like a changes in eccentricity, the orbital shape, again in the 100,000 year cycle here. So this here is so eccentricity, so it refers to the shape of the Earth's orbit around the Sun, which fluctuates from more circular to more elliptical period over a cycle of 100,000 years. So as you can see here, is that it starts to the elliptic pattern, it changes here, right? Because the farther you go, the more cooler, the closer, the more warmer, harsher. So when Earth's orbit is more elliptical, so there are stronger seasonal contrasts, which can intensify monsoon cycles in certain regions, including North Africa. Eccentricity amplifies the effects of precession, right, which is the wobble of the Earth, right, around its axis, making the monsoon cycles even more pronounced during favorable phases. So around 10,000 years ago, then, Earth's orbit was more elliptical, so helping to intensify monsoons and contributing to the Sahara's green humid conditions. Again, as we look here. The next thing that they talk about is the obliquity. So that's the tilt of the Earth's axis. So we talked about precession, right, which is which is Earth wobbling around its axis, right? We have the eccentricity, which is the change of the orbit around the sun of the Earth, so becoming more elliptical. And then we have the obliquity, which is the tilt of the Earth's axis. So again, from Skymarvels, beautiful picture here. So as you can see here, changes in obliquity, the tilt, and this is a 41,000 year cycle. Again, this is relative to the orbital plane, and you can see the difference, right, as the Earth is changing here. So the obliquity, is the tilt of Earth's axis relative to its orbital plane, so which changes over a 41,000 year cycle. So when the Earth's axial tilt is greater, there is more contrast between summer and winter, which also can affect the monsoon intensity in the African region, right? While obliquity is a lesser factor than precession and eccentricity for the Sahara, it still plays a role in modulating climate patterns on a global scale, including the extent of monsoon systems. So then what we have here is, so this is the obliquity, right? Sorry. Then we have the eccentricity, right, which is the elliptic, right, pattern of the orbit. And most important, which I believe also was a factor of the Green Sahara, is the precession, right, of the axial precession. So that's a different period there. So next here is that what I want to talk about here. No, let's hold that thought, because again I want to mention the Milankovitch cycles here. But so how do these cycles, so we're talking about precession, we're talking about obliquity, we're talking about eccentricity, how do these cycles create the Green Sahara? So they say around 10,000 years ago, a favorable alignment of these orbital cycles brought stronger summer solar radiation in the northern hemisphere, and then particularly affecting North Africa. So this warmed the land and intensified the African monsoon, which expanded further north than it does today. So this stronger monsoon system led to consistent heavy rains over the Sahara, which, as we can see, then the previous map that I showed you in around 9800 BC, you see the lush, how North Africa was very lush, right? So that was so the stronger monsoon system led to consistent heavy rains over the Sahara, transforming it into a landscape with rivers, lakes, and savannas, so which could support diverse wildlife and early human communities, so especially in the Maghreb area. So the resulting Saharan Green Period was characterized by lush vegetation, abundant water, and a stable environment suitable for both animal and human life. Archaeological evidence shows that early humans thrived here, and creating the rock art, example in the Tassili and Niger region, and practicing early forms of animal domestication. And then the return to the desert conditions, or to the actual present period, about 5,000 years ago, because then the Earth's precession continues to change, right? Continues to change, and the northern hemisphere summers becomes less intense, so which weakens the monsoon system, gradually reducing rainfall over North Africa. And then over a few thousand years, the Sahara transitioned back into an arid desert as rainfall decreased, and then the lush landscape and abundant water sources vanished, and both wildlife and human populations were forced to migrate to other regions. And then they say by around 3,000 years ago, the Sahara had become much like it is today, which is a vast arid desert with only a few scattered oases and limited water sources. And then again, they mentioned that this is a cyclical period. So future implications, right? Now, because precession and other orbital cycles continue to operate, the Sahara could potentially experience another green period again in the far future. And then they say, however, this would not take tens of thousands of years, and it would depend on a variety of factors, including how climate change affects these natural cycles. And the other thing too is that man-made climate change too, right? That's another factor too as well. Human-induced climate change, right, may also interact with natural cycles in complex ways, potentially delaying or altering the effects that would normally be expected from orbital changes. So then they say the Sahara's shift between desert and green landscapes is primarily driven by Earth's precession, with additional influence from eccentricity and obliquity. And then they say these Milankovitch cycles create long-term climate patterns, driving changes in monsoon strength and subsequently the Sahara's climate and environment over tens of thousands of years. So this is now where I want to get into the Milankovitch cycles. So this here, again from Skymarvels.com, here, we look at the Milankovitch cycle here. So here we, a little bit of a history. So Milutin Milankovitch, I hope I can pronounce that correctly. So a Serbian mathematician, astronomer, and engineer solved the mystery of what caused major ice ages over the last 500,000 years of Earth's history. They showed that regular changes in Earth's orbit result in periods of lower global temperature, and these periods correspond to the timing of past ice ages, right? So plural, ice ages. So that means then if you go through the timeline, there would have been through, again, adding precession, adding obliquity and eccentricity, that would have caused, the different periods of the Earth's climate. So that here is, which is great, so it shows right now the oblique view. I can remove that, I can do the top view, but this is better here, the rotation, the orbit. And what I want to do is I want to add eccentricity, right? Precession, and the tilt, right? So as we hear, this is today, and as I move here, look what happens to the Earth. See, the precession, eccentricity, and the obliquity. See, and we're going like this, like what is it, 25,000 years ago. So definitely, this would be a natural climate change as the Earth wobbles, right? And the Earth's tilt changes here. Again, we keep on going here. Again, this is going far here, like over 400,000 years. But amazing, you see how they talk about, and you could see the obliquity too. See how if I go slowly, the elliptical pattern changes. You see that? Up until today, and then going to the future as well. So this is then an animated view, of the Earth, going through its cycle. And again, you can play around with this actually tool. It's really great, really great tool, and helps you understand like the Earth, like the Earth, its cycle, its tilt, its eccentricity, and what I really like is the precession of the equinox, which was, I believe, major factor of the different of the different climatic changes of the Earth, and in particular in this video, the Green Sahara period. So other factors, because we talk about, okay, the Earth precession, right? How it moves around its axis, wobbles around its axis, right? Are there other factors, that may cause the Green Sahara? Yes, there could be. So, for example, there's this. So a couple of factors that can cause the climate events, are potential extraterrestrial impacts, solar variability, and sea level changes. Because during the Ice Age, if you talk about the Ice Age, the sea levels would have been lower, right? So if that would have been lower, right, the Mediterranean would have been like, it would look different, and not in right in that area. But let's talk about the extraterrestrial impacts, solar variability. When we talk about solar variability, we talk about like solar flares, right? Which can be possible factors. So one such period that they mention is called the Younger Dryas period. What this is, the Younger Dryas, and this happened approximately 12,900 years ago to around 11,700 years ago, was an abrupt and intense cooling period near the end of the last ice age. Right? So this event caused temperatures to drop significantly in the northern hemisphere, affecting climate patterns worldwide. So although the Younger Dryas temporarily slowed the onset of the African Humid Period, so he said slow down, the Sahara still experienced some increase in moisture as the cooling trend ended. When the Younger Dryas concluded, North Africa and other parts of the world quickly warmed up again, triggering more intense monsoons and wetter conditions, which likely helped initiate the Green Sahara period. The exact cause of the Younger Dryas, it's still a debated subject, but one hypothesis, right, which involves a comet or an asteroid impact. So this is where we talk about extraterrestrial impacts. Then, which could have led to cooling by sending large amounts of debris and aerosols into the atmosphere, blocking the sunlight. And they're talking about this at the Younger Dryas period. So other theories suggest massive glacial meltwater from North America entering the Atlantic Ocean, which then caused this sea level to rise, and which disrupted ocean currents and affected global climate patterns. The other thing is, we mentioned comet, asteroid; those are considered extraterrestrial impacts. So they're saying that while there's no direct evidence that links specific extraterrestrial impact to the start of the Sahara Green Period, impact events could indeed influence climate significantly. So large impacts eject massive amounts of dust and aerosols into the atmosphere, which can cool the planet by reflecting the sunlight. However, impacts could also create heat and affect atmospheric chemistry in complex ways. And they're saying if a significant impact occurred in or near North Africa during this time, it could have affected local weather patterns, potentially triggering a short-term climate shift. So example here is that if an impact caused temporary warming after an initial cooling phase, it could have contributed to the end of the Younger Dryas and encouraged the monsoon rains that initiated the Green Sahara period. And so they say that no specific impact crater from this time has been found in the Sahara region. The next influence, possible, solar variability and mass solar flares. Because now, our sun, right, it ejects solar flares from time to time, and some small, some large, right? And this can, affect also too the Earth's magnetic field, for example. So the sun's activity varies in cycles. So these changes can influence Earth's climate. So for instance, solar minimums, so periods of reduced solar activity, are associated with slightly cooler conditions in the Earth, while increased solar activity can contribute to the warming. Mass solar flares and coronal mass ejections are sudden releases of solar energy and charged particles, which can impact Earth's atmosphere, especially the upper layers. Right? However, they generally don't cause long-term climate effects unless they alter atmospheric chemistry significantly. So long-term solar variability, so on cycles of thousands of years, could have amplified or mitigated the effects of Earth's orbital cycles, influencing monsoon intensity in the Sahara. And they say, however, solar cycles are not a secondary factor compared to Earth's orbital changes, and their impact on climate tends to be less drastic over short timescales. Next is sea level changes and the Mediterranean as a lake, right? So not as a sea, as a lake. So they're saying here during the last ice age, much of the world's water was trapped in ice sheets, right? Causing global sea levels to be much lower than today, up to 120 meters, or we call 394 feet lower. So the Mediterranean would have been significantly smaller, and some researchers propose that it may have been a hypersaline lake or series of lakes in certain areas. So as the ice sheets melted, so this is around 18,000 to 6,000 years ago, sea levels rose, filling the Mediterranean to its present boundaries. So this influx of water also raised water levels in the nearby Nile and other rivers, potentially altering North African climates by adding more humidity and supporting the development of wetland ecosystems that early Saharan communities might have used. They say there is evidence that during the lower sea levels, the Gibraltar Strait could have restricted water flow into the Mediterranean, potentially causing the Mediterranean to be less saline or even temporarily dry out in certain areas. So this dramatic environmental transformation would have affected regional weather and could have supported or hindered human settlement, and depending on the time period and specific conditions. So then the interplay of factors. So we have a holistic view here. So this is a shift from the arid Sahara to the Green Sahara, which likely resulted in these factors here. So we have one, orbital cycles, right? So the primary driver, setting the stage with increased solar radiation in the northern hemisphere summers, which strengthen the African monsoon. The younger dryas and extraterrestrial events. So abrupt events like the younger dryas may have delayed the African Humid Period, but didn't prevent it. So extraterrestrial impacts, if they did occur, right? Because it's again it's theoretical here, especially in the North Africa here. So it could have influenced local weather temporarily, but likely didn't have a lasting effect on the Sahara's long-term climate. Solar variability. So while the secondary influence, solar cycles could have amplified warming trends that helped intensify monsoon rains. And rising sea levels. So as sea levels rose, Mediterranean's boundaries expanded, creating a stable source of moisture and altering local wind and weather patterns. So this might have added humidity to the regional climate and contributing to the stability of the Green Sahara ecosystem. So what they're mentioning here is that the dominant factor here driving the Green Sahara's climate would have been the Earth's orbital precession. So that would have been the dominant factor. Again, that 21,000 year period. And events like the younger dryas, potential extraterrestrial impacts, and sea level changes in the Mediterranean likely played a contributing role. So they mentioned contributing role, but not the dominant factor of precession of the equinoxes. So these combined influences created a window of time in which North Africa experienced monsoon rains and a vibrant ecosystem, conditions that sustained human and animal life for several thousand years. So remember that the important thing is they mentioned the monsoon rains, right? So because the important thing is the rainfall, right? So going back here to the Earth viewer here, and then going back about the ice age here, I just miss this here and move this here. Oh, didn't mean to do that, but Just going to remove the cities, grids right here. And as you can see here, increase here, right. So if you look at here, you know, I'm moving the Earth like as it was here. Again, 98,000 years, so not 98,000, sorry, it's 9,800 years. You know, the Earth's, the actual Earth impact, right? So the precession, right? The obliquity, eccentricity, right? That would have been played a factor of the Green Sahara period, and also too of the human population. So in this case here, this can answer some questions, you know, like for example in Tasiri and Jar with the rock art painting of when they mention, like, you know, like hunting, gathering, domestication, right, of cattle, showing different animals like giraffes, crocodiles, hippopotamus. That would make sense, right, in this time period here. So if you think about it, it would be more of a time capsule, I would say, right? So they left us so the inhabitants at that time left us a time capsule of how the Earth, how they lived at that period of time, and what the Earth looked like, thus proving, you know, the evidence here, right, of the example, like here 8,000, 9,000, 10,000, 12,000, of the climatic changes, right, of the Earth. And again, this is no mistake, right, that if we talk about the if we talk about the called here the Milankovitch cycles, different ice ages, in plural, you know, in different periods of times in the millions of years. But in our remote period here, showing here, like, you know, the Green Sahara region here, you know, there would have been this would have made sense, you know, that there would have been, like, you know, a human civilization thriving at this time. So not only just in the coastline here, but, you know, just all around, because again, it was not a desert at this time. It only gradually turned to a desert. See, again, I'm going backwards in time, right? See, you could see the difference here. You can even see at the top the Mediterranean even look different as we keep on going here, right? See, 16,000. See, there you go. See, then 14,000. See, 10,000. See, this is now eventually, you know, going back here. 8,000. I mean, it looks, if you look at it here, you know, it still was, you know, a sea, you know, like not a lake as they mentioned here. I mean, again, if we go back here, let's see, does it shrink? It does not really shrink, actually. It only actually gets, it's kind of stable here. So I'm thinking, you know, if we go to the Paleo era, then, well, yes, I mean, that would definitely make sense, because 10 million years ago, 5 million years ago, right, as you can see here, right, 10 million years. You see, again, these are in millions of years, and you can already see, like, you know, the northern Africa, the Sahara was green, right? Now you see a difference here as you go 20 million years, right? And yeah, you see then, and again, Africa looked different at this time. As you keep on going here, changes. But again, I don't want to go back too much here because again, that's goes a little bit too far here. But yeah, that's in our area. The most important part is the Ice Age, right? About going this period here. So yeah, tell me. So I'd like to hear your thoughts, and what do you think? About the Green Sahara period. Civilization, society, the different cultures, right? That existed here. Example, in my roots, the Berber people, right? The Amazigh people. How do they live, right? In this period here. How was it like? Tell me your thoughts, in the comments. And yeah, like it'd be interesting to, have a little conversation or discussion about, our history, specifically in the North African region, because it's very, very, I find it fascinating that, we're talking about 9 million kilometers square of Sahara, like, to this period. And we talk about mainstream, like if they say that, that this was a desert, I'm not putting anything what they're saying, but there's a lot of history here of the Sahara. Like, I believe that there should be there should be some archaeological investigation, into the Sahara, because what hidden things would we find, in this in the Sahara, especially in North Africa, and I'm not just saying North Africa, but like we're talking from the West Coast up to the East Coast. So the East Coast going to the Red Sea, so Egypt. So yeah, like that's a really interesting thing to look at, and also to kind of add the puzzle, of our remote past, to see, like, like what really is, like how did we evolve? How did we survive? Again, before the desertification, right, of the Sahara. What was the population like at that time? I mean, was a population more than it was when during the desert, right? Because obviously nobody can survive the Sahara, just by standing for a long period of time. There has to be some. You have to get food. You have to get water. You look at here. Well, I'm sure definitely there was, water, rivers and lakes, and that sustained life, and sustained a human civilization. So again, if you like this video, please subscribe, and let me know in the comments. Yeah, I'd like to hear from you, especially for people in the Maghreb, from Morocco, from Algeria, from Tunisia, from Morocco, even from Egypt too as well. also, would like to hear from archeo archaeologists, archaeologists, right? Um, Geologists, earth geologists, and what are your thoughts, of the Green Sahara period? What you think would have been here? I mean, I really find it really fascinating. Like, I love ancient history myself, and specifically, this ancient Egypt. When ancient Egypt is totally, again, different subject, which I can probably talk about it in another video, and even especially about ancient Egypt during the Green Sahara period. Um, yeah. So thank you for watching, and yeah, and if you want to share your thoughts as well, let me know, and next video we'll what I'm thinking about talking about is a lost Saharan civilization. So I guess it's kind of controversial, but it's something that I think would be a good talking point, to see, like, during the Green Sahara period, uh, was there a lost civilization that we are not aware of, like, and again, all through the Sahara present time, is there any remnants of this ancient lost civilization uh, hidden? So again, we'll talk about that in another video. And again, thank you for watching, and we'll talk to you soon.